All right, grade nines. So here's another video, and what you're seeing here is if you look at the top, okay, of this area here at the top of the display, the top of this yellow sort of area, you can see a hollow tube, okay, and those blue dots that are sort of moving back and forth are air molecules. Okay, so a hollow tube is filled with air. Okay, and it has natural modes that it resonates in, just like a string. And so what you're seeing here is the first harmonic of the tube. Okay, now sound waves are longitudinal waves, and so we don't usually draw them like crests and troughs. But if you look at the picture in the middle here, they're showing you what it would look like if we were to draw it like a transverse wave. So it looks like half of the skipping rope. Okay, so that's one skipping rope, like one crest would be half of a wave. So this is actually a quarter of a wavelength, okay, of the waves, because we're seeing half of a crest. That's 1/4 of a wavelength of the waves. Now, so you know what this sounds like? If I have a test tube in my hand, I know you can't see it, but I have a test tube in my hand. If I just blow over the top, it sounds like this. Okay, and what you hear is a musical pitch, and that musical pitch is the first harmonic, okay, of the tube. What's happening is the air molecules are doing exactly what you see here. Now, like strings, this has higher harmonics. So if I look at the higher harmonic, this is the next harmonic, okay, of the tube. And I'll just zoom in a little bit. You can see here that some of the molecules of air, that like right about here, these molecules right there aren't moving at all. They're on a node, okay? And the other molecules around it are moving quite a bit. So here we have one full antinode, and then a node right there, and then another quarter of a wave right there. So since one antinode is half a wave, and this little piece here is a quarter of a wave, we have a total of a half plus a quarter is 3/4 of a wavelength fit across this. Now the tube hasn't changed length. The tube is exactly the same length at the top. What's happening is you blow harder over the top and you get a higher harmonic, okay? So we can go higher again. This would be the next harmonic mode, okay? Now we see two antinodes plus that little quarter there, okay, at the end. So this is a 1/2 of a wave, the first antinode, 2 halves for the second antinode. So we're at a full wavelength plus a quarter. So this is 5/4 of a wavelength, okay? And you see what we're doing is, here, let me show you the pattern. The first one is just a quarter of a wave, okay? Then we add, just like strings, to get the next harmonic, you add antinodes. Same thing here. We add one antinode, and we get 3/4 of a wavelength. We add two antinodes, and we get 5/4 of a wavelength. We add three antinodes, and we get like 7/4 of a wavelength. And what's happening is, see, look, this is a half, this is a half. That's one full wavelength. Full wavelength is 4/4 plus another half. That makes 6/4 plus another half makes 7/4 of a wavelength. Okay, so like 7/4 wavelengths here, and we see 1, 2, 3 nodes. Okay, I guess we can count the end as a node as well. Okay, and then over here we have an area of constructive interference right at the end. We're halfway through an antinode. That it always ends the same way. Okay, see that? It always ends with a little half of an antinode there. And that's at the open end of the tube where that happens. Okay, so you can see this has harmonics, just like a string has harmonics. The only difference is the first one looks very different. Okay, the first one starts like that. It's half of an antinode, whereas the string has a full antinode to start with. All right, so that's how it works in a closed tube that's closed at one end. It's closed at this end. It's open at the other end. Now, a musical instrument that's based on this kind of resonance is never closed at one end. It's always got two holes in it. One at the end you blow through, and the other one is open at the other end too. And there's a reason for that I'll explain later. But let me show you what that looks like. If you have two open ends, okay, and you blow over the over one end, the first harmonic looks like this. And what we can see is we have half of an antinode on this side and then a node in the middle, and then half of an antinode on the other side. So two halves make a whole antinode, but remember an antinode is half of a wavelength. So this is one half of a wavelength, okay? The closed tube started at a quarter of a wave. This one starts at a half. 2 quarters make a half, right? And then just like the other one, if you increase the harmonic, you're going to add antinodes. So the end behavior, called boundary behavior at the two open ends, is always the same. We always get this half of an antinode now on either side because both ends are open. But in the next harmonic, we see that there's an antinode in the middle and then plus those two halves. So this is 2 halves of a wavelength. Okay, 2 halves make a whole. So this is a whole wavelength. It's really 2 full antinodes, right? Quarter here, and a half here. Well, 2 quarters plus a half make 1 full wavelength. Okay, and the next one, we're just going to add, again, another sort of skipping rope gets added, right? And we end up with this here makes a whole wavelength, a half plus another half with the 2 ends. Okay, it makes 3 halves of a wavelength. Okay, and so on. So this one is very much like a stringed instrument in the sense that it starts with half of a wavelength at the very lowest harmonic, and then it increases by halves as you go up. Okay, so that's how resonance in tubes work. Okay, so musical instruments that are wind instruments, and it's really unfortunate we're not together because we could show you, like students who play wind instruments in the band and stuff could show us their instruments. And it's really cool to look at it because the tubes don't have to be perfectly straight. Okay, they can be twisted around and stuff like that. And the longer the tube, the lower the first harmonic is. And so if you have a really long tube, you have a low first harmonic. But you can drill holes in the tube, and where that last open end is determines the length of the tube. So you can change the length with your fingers by covering up the holes, and that allows you to play different notes. Okay? All right.